Hello students, in class 11th today I will tell you about the numerical problems of the chapter 15, the wave motion. You all watch the video completely, and if you like it then you share to your friends who are studying in the same stream. And until you see the full video, you cannot understand the application of the formula that I have told you in the chapter wave motion. So now the numerical problems. So your first problem is equation of a progressive wave. Progressive wave. Is given below. Y equal to 0.04 sine 157 t minus 3.14 x. Calculate number 1 amplitude, number 2 wavelength, and number 3 that is the frequency. Solution. We know the equation of the progressive wave. The standard equation of a progressive wave y equal to a sin 2 pi upon lambda into bt minus x. This we know, and the given equation is this one. Here all quantities are in MKS. The given equation y equal to 0.04 sin 157 t minus 3.14 x. This is the given equation. Now what we have to do, that this equation is to be converted in this equation. It means that the x must be free from 3.14. So we have to take it common. Y equal to 0.04 sin. We have to take common 3.14 from all. So this is now 3.14 into 157 upon 3.14 t minus, we have made it free just by taking common 3.14. So this y equal to 0.04 sine 3.14 into, if you see that this is just half of this one, 157 is half of 314. So what we do that we take the 100 point, then this is so much. So here this will be 15700 upon 314 t minus x. And this will cancel by this 2 times and this 2, this is now your 50. So this is y equal to 0.04 sine 3.14 into 50 t minus x. Now this is equation in this form. Now we compare. Comparing equation 1 and 2, we get A amplitude A equal to 0.04 meter. This is the answer to the first question, amplitude. And then wavelength, you can see 2 pi upon lambda. This is 3.14. 2 pi upon lambda equal to 3.14. 3.14 is the value of this pi. So this factor will cancel by this one. So lambda equal to 2 meter. This is the wavelength. And now the V, this V is equal to 50. Velocity V equal to 50 meter per second. Therefore frequency N equal to V upon lambda, and V is given to 50 and lambda is given to be 2, so this N equal to 25 hertz. This is the answer to the third part. So this is the first question. Now the second question. The speed and frequency of a wave. The speed and frequency of a wave are 360 meter per second and 500 hertz. Respectively. The phase difference between two nearest points. The phase difference between two points is 60 degree. Calculate the path difference between them. Calculate path difference between them. Now the solution. How we take? You are given the speed v equal to 360 meter per second, and you are given n equal to 500 hertz, and you have given the phase difference delta phi is equal to 60 degree. 60 degree means this is equal to pi upon 3, and you have to calculate delta x. This you have to find. So first we find the path, the wavelength. Wavelength lambda equal to v upon n, and this is your v is equal to 360. This is your 500. This will cancel, so it will come out to be 36 upon 50. This is the lambda. Now, phase difference. Delta phi equal to 2 pi upon lambda into x into delta x. Delta x is the path difference that you have to find out. Therefore, delta x is equal to delta phi into lambda upon 2 pi. So the delta phi is equal to pi upon 3 lambda. This is now your 36 upon 50 into 2 pi into 2 pi. What we have here, this lambda is equal to 36 upon 50, 36 upon 50. And delta phi is 60 degrees, so this is now pi upon 3. So this is pi upon 3. Now we simplify. This pi will cancel by this one. 3 to this by 12, and this 2 by 6. So this is your 6 by 3. This is now your 25. So this is 3 upon 25. So this is actually 0.1, and then this is now 50, 0.12 meter, or this is equal to 12 centimeter. This is the answer to the question second. And now I take the third question. So clearly, first you find the wavelength, and then you apply the formula of phase difference, and then put the values that are given here, and then simplify, and then you will get the path difference. And now third question. The ratio of densities of densities of oxygen and nitrogen is 16:40. At what temperature? At what temperature the speed of sound in oxygen will be equal to the speed of sound at 15 degrees centigrade in nitrogen. Now solution. How to simplify? We know that V equal to square root of gamma RT upon M. This you have to apply for oxygen and then nitrogen. And here this T equal to 273 plus T degree centigrade. Because this is the absolute temperature. So now let for oxygen. For oxygen, VO equal to square root of gamma R. At what temperature the speed of sound in oxygen? This is now 273 plus T upon M. For oxygen, this is now you given the 16 density, so this is now 32. And then speed of sound in nitrogen at 15 degrees centigrade. So for nitrogen, Vn equal to square root of gamma R into 273 plus 15 upon, this is now 28. Molecular weight of this nitrogen is 28. Now these two are equal. According to question, equal. So what we have to do? According to question, V naught equal to Vn. We equalize to. So this is your square root of gamma R into 273 plus T upon 32 equal to square root of gamma R into 273 plus 15 upon 28. Now gamma R will cancel, square root will cancel from both sides. So we have this 273 plus T upon 32 equal to this we add this is now 273 plus 15 upon 28. Just you cancel, this is now your 16, this is now your 14, and again by this 8, this is now your 7, and then cross multiply. So 273 into 7 plus 70 equal to 8 into 273 plus 8 into 15. So just you simplify, then this you will get this 70 equal to this 7, this factor is so much, this factor is so much, so this will be now 273 and plus this is now your 8, 15 8 is 120. So this is your 3, 7 and 2, 9, and this is now your 3, this is 70. So T equal to 393 upon 7. So 7 5 are 35 and 4. So this is now your 36. 7 6 are 42.1 degree Celsius. This is the answer. So yes, so much temperature the will be equal in the oxygen and the nitrogen gases. So what we do first, you write down the formula, then put down the value and then equalize them and then simplify, and last you will get the temperature in degree Celsius. And now fourth question. The mass of 35 centimeter long wire. The mass of 35 centimeter long wire is 2 gram. 2 gram. Calculate the tension. Calculate the tension. Tension in wire to produce fundamental frequency. Fundamental frequency of 500 Hz. So what is given that you have to find out the tension in the stretched wire. I have told you the mode of vibrations in the stretched wire. We know that n equal to 1 upon 2n into square root of T upon n. T the tension and the mass point length, L is the length of the wire. So everything is given here. This L equal to 35 centimeter. So this is 0.35 meter. T T you have to calculate. M equal to 2 gram upon 35 centimeter. So this is your 2 upon 35, 10 to the power minus 3, 10 to the power minus 2. So this is now 10 to the power minus 1. So this is your 0.2 upon 35. So much kilogram per meter. And then you have to find the N that is given to you. N is given. N is given to be now 500 hertz. Put all these values in this equation. So we will have this. Putting the values of different terms in formula. This is equal to now 500 1 upon 2 into 0.35 into square root of T upon M is equal to 0.2 upon 35. So much. So how to this you just you can do that. This you remove here, then this is now 100. So this 2 zeros will cancel, and this is now your 10 into 35 equal to. This is now your T upon 0.2 upon 35. Therefore, T equal to 10 into 35 into 0.2 upon 35. 35 will cancel. 700 gram 10 is to the power minus 3 centimeter to meter 10 is to the power minus 2. So 10 is to the power minus 1. So this is now 0.2. So this is now 500, and this 0.35, this will be 100, this will cancel by this one. So 5 to the 10, 35 into T upon 0.2 upon so much. This multiplied this one, 0.2 upon 35, this will cancel. This will come out to be 2 Newton. T equal to 2 Newton. So much tensor must be there for the your fundamental frequency in the stretched wire. So this is the fourth question. And now the fifth question. Fifth question. The ratio of intensity of two waves intensities of two waves is 1:9. If these waves produce interference, interference, what will be the ratio of will be the ratio of maximum and minimum intensities. Solution. Given I1 upon I2 equal to 1 upon 9. And we know that the intensity is proportional to the square of the amplitude. So this is equal to A1 square upon A2 square equal to 1 upon 9. So A1 upon A2 equal to square root of 1 upon 9. So A1 upon A2 equal to 1 upon 3. Now maximum intensity and minimum intensity. Now I maximum upon I minimum equal to A1 plus A2 whole square upon A1 minus A2 whole square. So A1 is 1 and A2 equal to 3. So this is now 1 plus 3 whole square upon 1 minus 3 whole square. This is now 4 whole square. This is upon 2 square. So this is now your 16. This is now 4. So 4 to this is now 4. So this is now 4 upon 1. It means what? That I maximum ratio I minimum equal to 4 ratio 1. This is the answer. So what to do? That first you write down what is given there in the question, and then apply the formula that intensity is always proportional to the square of the amplitude, then this so much, and then find I maximum and I minimum. A1 plus A2 whole square upon A1 minus A2 whole square. A1 is 1 and A2 equal to 3. Then put these and simplify. This is the answer to the 5th question. And now 6th question. The closed and open argon pipes are of equal length. Closed and open argon pipes are of equal length. Equal length. The difference in frequencies of frequencies of first overtone, of closed organ pipe, of closed organ pipe, and second overtone of open organ pipe and second. Second overtone. Second overtone of open organ pipe. Organ pipe is 90 Hz. 90 Hz. Calculate the fundamental frequencies of both the pipes. Calculate the fundamental frequencies of both the pipes. What you are given? You are given the two organ pipes. Both organ pipes are of equal length. One is closed organ pipe and second the open organ pipe. The first overtone of the closed organ pipe. First overtone of closed organ pipe and second overtone of open organ pipe is 90 degree. The difference in their frequencies is so much. Calculate the fundamental frequencies of both the pipes. Solution. In closed organ pipe, the frequency this is now 1:3:5 and so much. So this the first overtone is 3 times of the second of the first harmonic. So first overtone N1 equal to 3 of this N1 equal to 3N. This is now suppose N, 3N, 5N and so on. Enclosed सही. In open organ pipe, the frequencies (1:2:3) and so on. The second overtone. This is the first overtone, this is the third, this is the second overtone. So second overtone. Second overtone. This is the second overtone. N2 equal to 3 and this fundamental frequency. This is suppose N dash. And we know that here in this case this N is and this N dash but n dash is equal to 2 times of n. 2 times of n. For closed, this is b upon 4l, this is b upon 2l. So this frequency is just half of this frequency. So this fundamental node of this one, this n, is 3 times of just 2 times of this one. So now we will write down this n2 equal to so much. n2 equal to 3 into 2n. So this is now your 6n. So now you are given according to question. n2 minus n1 is equal to 90. n2, this is now your 6n, this is now your 3n, so this is your 90, so this is your 3n equal to, it is your 90, so n equal to 30. It means that the fundamental frequency of this overtone is 30. Fundamental frequency of closed organ pipe is equal to 30 Hz, and fundamental frequency of open organ pipe n dash is equal to 2n. So this is 2 into 30. So this is now your 60. So much else. So this is what the answer of this, and we know this, you always remember in your mind that if the closed and the open organ pipe are of equal length, then the frequency of the open organ pipe is just double the frequency of the closed organ pipe. So this is the 6th question. So you will get so many numerical questions based on the waves. So today I have told you about the numerical questions based on the wave motion. And now I will take certain question papers, because the students know that this is the answer, this is the way of solution, but they cannot express them in a right way. So I will take some board papers and I will tell you that how to write the answer in a proper way. So you like, share, subscribe this video. Thank you very much.